Hello everyone, welcome to today's lesson on trig ratios or trigonometry ratios. Alright, so last time we talked a lot about finding out what side is the hypotenuse, the opposite, or the adjacent. So this time we're actually going to put them into practice. Alright, and now those ratios are very important because when it comes to right triangles, right, they always maintain the same proportional relationship. Right? So no matter how long each side of the right triangle is, the ratio between each side is always proportional. It's always the same. Right? So we can use what we call trigonometry ratios to find those sides and angles. Luckily, in our calculators, they're already stored. Right? So for example, in my calculator, let's see if the camera focuses. The camera's not focusing, that's fine. Right? But you can kind of see here, it's here, right? Sine, cosine, and tangent. Alright, so all of those is stored in the calculator. I will never make you do this by hand because that's gonna be an absolute pain. Okay, so here are the three ratios. First is the sine ratio, abbreviated SIN. So now sine of a given angle is the opposite over the hypotenuse. So that's why it's important for us to figure out the opposite, the hypotenuse, and the adjacent, right? They're useful in the ratios. With cosine, that refers to the adjacent over hypotenuse. And tangent, that's our last one. That's the opposite over the adjacent. Alright, so be very careful here. Do not mix up the order. The order here really matters. It's always opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Alright, a quick catchphrase to think about is SOHCAHTOA. So, ka, and toa. Alright, SOHCAHTOA. You'll hear this a lot. SOHCAHTOA, so the so is sine, is opposite over hypotenuse, right? Sine is opposite over hypotenuse. Cosine is, oops, sorry, I spelled that wrong. Right, that's adjacent over hypotenuse, and TOA is tangent, right, opposite over adjacent. Right, so this is very important to know. Right, so SOHCAHTOA. Right, so what does that actually mean? Right, let's take a triangle for example. Right, let's say this angle here is theta. Right, so theta is a common variable we use for angles. So just like how we solve for x, solve for y. The angle, instead of being x, we just use the symbol theta to denote it's an angle. Right, let's say it's a right triangle here with 4, 5, and 3 is the side length. So the first step in any of this is always determine the side's names, right? Right here. This edge is directly across from the right angle. This has to be the hypotenuse. This edge is directly across from our theta, the angle in question. So that's the opposite. And the last side, that's the side that's touching the angle. That's not the hypotenuse. That's the adjacent. Okay, and then from there, we know that sine is opposite over hypotenuse. So 3 over 5. Right, opposite over hypotenuse. Next is cosine. Right, well, cosine here is adjacent over hypotenuse. So the adjacent is 4, hypotenuse is 5. 4 over 5. And tangent, the TOA is O and A, opposite over adjacent. So opposite over adjacent is 3 over 4. Okay, that's it. All right, so this is the ratios of the triangle. Okay, let's do some more practice. This is very important. Yeah, actually, before we begin, right, we always find the side names. Opposite to the right angle, across from the theta angle, and adjacent. Sine is opposite over a hypotenuse, opposite over hypotenuse. This one is adjacent over hypotenuse. Tangent is opposite over adjacent. Just like that. Okay. Across from right angle, that's hypotenuse. Across from the angle in question, the theta is opposite. Adjacent to that is adjacent. Okay. Sine is opposite over adjacent, which is reduced to 6 over 7. Cosine over hypotenuse, reduced to 9 over 14. Tangent is opposite over adjacent. Just like that. Okay. That's the opposite, or that's the across from the right angle, so that's hypotenuse. Across from theta, opposite, adjacent left. We don't know this angle here. We don't know this length here. But luckily, we do know the Pythagorean theorem. Right, we know the hypotenuse is this, so those two are the side length. Right, so add up is 400 equals to c squared. C is the square root of that, which is 20. So that's the hypotenuse. From there, business as usual. Opposite over hypotenuse. Reduced. Adjacent over hypotenuse. Tangent over tangent opposite over adjacent. Okay, so that's how we determine the angles. Or not the angles, the three trig ratios. Speaking of angles, why do we actually care about trig ratios? Right, so this is now time to actually find out what the theta is, right? What this mysterious angle is. Okay, so once again, I'm going to list out the catchphrase. So ka toa. So let's say this one here. What are we referring to here? Right, we have the hypotenuse, right? And then we have a cosine. Or, sorry, we have the adjacent line here, right? That's the line that touches the angle. Okay, so what trig ratio do we use here? What's the only one that uses the adjacent and hypotenuse? Right? Of course, like I spoiled earlier, we use cosine here, right? So cosine of this theta is just like this. Okay, we cannot use sine here, right? Because the opposite is this line here. We don't know what this line is. We're not given that. So there's no point of using sine. And there's also no point of using tangent because we also need the opposite for tangent. Okay, so now we found the right ratio we want to use because the cosine is the only one that has an adjacent and hypotenuse. So now how to find an angle? On a calculator, please focus. Oh, it's not focusing. But on the calculator, usually above your trig ratios, there is there's usually something else, right? There's usually the same ratio with a -1 exponent. Right? And this is called an inverse trig function. It should be on almost all calculators. And we use inverse trig to go to the opposite direction. Because normally, we refer this angle as an actual angle, like 30 degrees or 40 degrees, whatnot. But in this case, we don't know the angle is, so we have to go backwards. So what we have to do now is take the inverse trig, the inverse cosine of this number. Right, and when you type into a calculator, the inverse cosine of this fraction, we get 58.6. Okay, and then that's our answer. That's the degree we get. Right, so again, we are rounding to the nearest tenth. Right, so inverse ratios are very useful. Let's try another one. What size do we have? This right here is the hypotenuse. This right here across from the angle is opposite. Right? The only ratio that uses hypotenuse and opposite is sine. Right? Sine is opposite over hypotenuse. Okay, and once again, if we want to find the angle, we do the inverse of it. Yeah, so then using a calculator, you should get this. If you do not get this, and you get like a decimal or something, that means you're in radians mode, not degree mode. Alright, so make sure your calculator is in degree mode. Okay, let's get going. So we have the angle here. Across from that, that's the opposite. Alright, we know that this right here is the hypotenuse. Alright, this other line that touches this angle is the adjacent. So we use tangent. Of course, the inverse of that. And that's opposite over adjacent. To get that. Alright, we're given hypotenuse, and we have this line here that's touching this angle, adjacent. So we must use inverse of cosine, which is adjacent over hypotenuse. Across, that's the opposite. This is adjacent to it. So we use tangent. That's the opposite. That's the adjacent. That meant the hypotenuse. I just realized what I said. Okay, so we use sine. It's opposite over hypotenuse. Almost there. This is across from the right angle. This is adjacent. Okay, so we use cosine because that's adjacent and hypotenuse. Across from the angle. Across from the right angle. Opposite over adjacent. Okay, and that's it. And so the tricky part about using those trig ratios is always just to know which side is the hypotenuse, what's the opposite, what's the adjacent. And once you find that, very much make sure that we are using the right ratio for the job. Right? You'll always only just have one of those ratios to apply for what you're trying to solve. Okay? So, or I guess you can use multiple different ratios depending on what information you have. But if you're only given two different side lengths, then you have to use one of those ratios. Okay, but that being said, that's pretty much it for today's lesson. Alright, so yeah, again, try to get used to those ratios. Remember the catchphrase "so katoa," and then go from there. So with that being said, good practicing.